Good afternoon. Last time, if you remember our last lecture, we talked about mucosine sound like test. But today, I just want to summarize the Puska-Wally test. That's what we want to. But the main thing that I want you to understand is this formula. And this is talking about where we have items, which is either 3 or more than 3. That is where we use this mathematical tools. So we use, that's why I say K is greater or equal to 3. So we have some data that is for 3 or greater than 3. That's what we use this particular mathematical tools to solve on. Now, this is the formula for the Puska-Wallis theorem. So we have the 12 divided by n, open bracket n plus 1, the sum from the 1 equal to k, which means this is rank, the rank, you square the rank, the sum of the rank, then minus 3, open bracket n plus 1. So now from here now, we have this parameter, we have where this is chi-square variable, which is called k minus 1, degree of freedom, meaning that the number, any number of k, we minus 1. If k is 4, minus 1. If k is 2, you minus 1. If k is 3, you minus 1. So now, to get the degree of freedom, then we have k, number of population is the k, the total number of population. Then ni means number of items you use. The n, that is you had all the number to get the n. The total number of items in the sample, that is the sum. Then performer, so look at this table. If you check your material I gave you, this is there. Is that taken? Now, I talk about this, a particular question in your question I gave you under this Puska theorem. I gave you a question there. And this question is talked about a particular company, Bola and Ronti company, manufacturing company, hire its management staff, room, 3 college. We have, which means K is 3 here. So that is why we have college A, college B, and college C. So we want to solve this particular question using this particular Puska-Wally test. Now, first of all, we need the rank. We must find the rank. The ranking. So we need to rank it. So the ranking says, look at this ranking. We have the college A. Then we have the rank. I will explain that one, how I come across that rank. Then for the college, then college what? College B, we have the number, then we also have the rank for the college. Then for the last college, which is college C, we have the rank. Then this is college C, this is the rank for the college C rank. Now, put the data here. We have 20 as 25 as before, 25, 70, 60, then we have 85, we have 95, we have 90, we have 80 for college C. Then for college A, then for college the ranking, I will explain how we get all this ranking. So from the ranking, we have 3 for 25, we have 12 for 70, we have 9 for 60, we have 17 for 85, we have 20 for 90, we have 18.5, this is 95, 20, 18.5, then 80, for 80, we have 15.5. So the total ranking here is called 95. We have the total for the total ranking. Then for the college B, we have 60, we have 20, we have 30, we have 15, we have 45, then we have 40, we have 35. Then for the ranking, we have 9 for 60, we have 2, 9 for 60, we have 2, we have 4, then we have 1 for 15, we have C, we have 5, then we have 20, we have after 5 for ranking, we have, this one is empty, we have 27. So meaning that the data is not complete yet. We have only 1, 2, 3, 4, 5, 6. So there is no 7. Then for the college C, last college, we have 50, we have 70, we have 60, then we have 80, we have 90, we have 70, we have 75, Then the total, by the time you sum up, we have 88 for the total ranking. Now, I mean for the so we have 75. Then ranking, we have 70. Let's write the ranking. We have 7. For 50. For 70, we have 12. For 60, we have 9. For 80, we have 15.5. For 18, we have for 90, we have 18.5. Then for 70, we have 12. For 75, we have 14. Then 88 for the total ranking. Now, how do we now solve this one? So good afternoon. The last time I gave you assignment on this question, that you find the probability of x if x can be exist between the range of what? The pi divided by 4 less or less x is less or equal to pi. So that's what we want to look onto. The probability that the x can exist between that thing if the probability function is given by this. Now, I gave you a probability function, and the function of probability, the probability function is given by it can be exist between the negative infinity to infinity, and the function can be what? Can be x, the x. So this is the function, this is the probability. So meaning that it can be occur within the range of the negative infinity to infinity. Now we are given this specification that it can occur between the pi divided by 4 and what? Pi. So just change this function into the what? Into this equation, the integral of this. So we now say the probability function can be what? Can be pi divided by 4 to pi. Then what is our function? Our function is sine exponential plus x. So you put the exponential sine, the exponential sine s, exponential cos x, the x. Now, if you look at this one critically, this, how do we integrate this? This is our question. How do we integrate this? Now, this is particular sine x. We make it not to be solvable, and we need to solve this. Now, we can now make this one. We can now say let cos s equal to u. We assume that our cos s is equal to u. Now differentiate u. We say the u, the x, we give for what? Minus sine x. So that's what we give us. So we now make our ds the subject of formula for this particular equation. Call this equation star. So we make it the subject of formula. Now from here, by the time we cross multiply, we have the x equal to the u over minus sine x. Now, from here, call this one equation star. Now, substitute the x into this equation. Let's call this one equation 1 as our equation. Now, substitute this into this. We have the probability function with the pi divided by 4, then pi, which is equal to sine x, the exponential u, because we have turned the what? Cos s into u. So we now put the u over sine x. So because this one has negative, the negative will be here. We put negative here. Now as you can see here, this sine s will cancel sine x. We have minus pi divided by 4, then pi, then equal to exponential u du. So when you differentiate the u and exponential u, we have something like this. We have minus into the range of what? U, then over, to what? To the pi raised to power 4, divided by 4, then to pi. Now, the question is this: what is our u? Our u is cos x from this. So substitute it into this. We have exponential cos x. Seeing our u from here is equal to cos x. So we now put pi divided by 4, then pi. Now substitute into to look at the range, the limit function. So we now have what? Then exponential cos pi minus what? Minus exponential cos pi divided by 4. Now, let's open this bracket with this minus sign. So it will now change. So it will now be exponential cos pi divided by 4. Minus times minus will give you plus. Then this one will be minus exponential cos pi. Now, our cos, according to the radian, 1 pi is equal to 180. That is the meaning. 1 pi equal to 180. So meaning that 180 divided by 4 will give us what? Exponential cos 45 degree, then minus exponential 180 degree. Now, what you have to do here is to find what is the cos 180. 180 for my calculator here is equal to 0.7071. Then for my calculator here, the exponential 180 cos 180 will give us what? Cos 180 will give us minus 1.